And without further delay, I would now like to introduce today's presenter, Mike Benkovich. Mike, you now have the floor.
Thank you very much, Bennett. And I want to welcome everyone to today's webcast. This is, I don't know, the 8th or ninth one in the series I've been doing on the Framework Masterclass. This one today is talking about load balancing, deployment, and performance. Really, the concerns and thoughts about what you have to have in mind when you're going out and taking these WCF services and making them available either for your own application consumption or out there for other systems and services to come out and get into being able to work with this. If you're interested in information about the other webcasts that I've done in this series, you can go out to www.benkotips.com, and then if you're on the site, I just switched over to it, you can just go over here to the webcast, click on Framework Masterclass, and that'll take you right over to where you can get a history of all the different webcasts that have been part of this. Hopefully you've been able to check out the other ones. If not, just a quick shameless plug on this stuff. What we're going to do today is we're going to talk about a number of different things. Mainly we're going to talk about load balancing and how we can take our applications and really get the kind of scale that we need out of them. We'll also talk about deploying the WCF services, and we'll look at how we can use the Windows Activation Service, which is one way of doing it, versus Internet IIS, Internet Information Services, for hosting your service. The big difference is that IIS is great for HTTP type bindings, and or Windows Application Services is really covering all of the other types of bindings that you may want to go out and host. They're pretty similar, but a little bit different. And then finally, what we'll do is we'll wrap up with some information on how you can get some scalability and performance out of the applications that you're working with. Now, usually I like to run a quick little survey here, but I've gotten feedback that survey isn't really that useful to people because I ask you what do you do and whatever. Yeah, it does help to know what level we're going into. Today's webcast is targeted at between the 200 to 300 level, which is assuming that you've got some background in not only the deployment of .NET languages, including C# and VB, but also that you got some experience with WCF, or Windows Communication Foundation. This is the service-oriented architecture-ish type framework that we use for being able to focus on the mechanics of what it is, what it is that we're trying to do. Focus on the message as opposed to the machine that delivers it. We're going to talk through really three main pieces. We'll start off by talking about deploying. If you do an HTTP binding, what types of load balancing capabilities are available from within WCF, and then we'll talk about actually going out and doing some deployment on that, and then looking at some performance on that. So with that, let's dive right in. When we talk about load balancing in WCF, I mean, what we're really talking about is how we can get more capabilities, more scalability by using the concept of a server farm to offset or to offload the work that has to be done in order to host the services. If you're doing standard HTTP binding, you can go out and you can literally be able to just take advantage of the load balancing capabilities of like a Windows Server, or whether it's a hardware appliance or a software appliance, to go out and do that. You can load balance using standard load balancing techniques such as software balancers or hardware. So if you've got like a big IP, you can use that to go out and do your deployment of the application out to all of the different servers that are part of your hosting framework and your hosting environment. And that's actually fairly quick and easy to go out and do. Depending on the type of binding that you're using, load balancing is either going to be very similar to any other HTTP or any other web application. But if you do other types of binding, then you're going to have to spend some time going through in the configuration and laying out a couple of additional configuration things to make it work. And forgive me, I've got a little bit of a cold, so my throat keeps getting a little bit dry. So we can literally go out and take advantage of standard load balancing capabilities to go out and increase our scale by simply deploying the application out to more and more servers as we're working with this. from the perspective of load balancing, WCF applications that communicate using the basic HTTP binding are no different than other types of HTTP traffic. So I can just use the same techniques I've got for ASP.NET web pages or ASMX web services. These are inherently stateless, which means that there's no real worrying about what the affinity is on different application sessions to a particular machine that's running. If I do have the default binding, then we can go out and work with this. Support for persistent connections is enabled in the configuration. By default, the basic HTTP binding sends a connection HTTP header with the messages saying that we want to keep alive value set up to enable the clients to establish persistent connections to the services that are going to be out there supporting it. This basic configuration offers better throughput than what we otherwise would have, because the previously established connections can then be reused to go out, and basically like a pool of connections, we can go out and just grab the one that we want that's not currently being used and then reuse that. This connection reuse can cause some of the load balancing. So for instance, if we're in a load balanced farm using a round robin type of a load balancing, that behavior might be disruptive to how that's processing, because the keep alive property pardon me, because the keep alive property in the custom binding or the user defined binding can throw that off. The next thing we're going to talk about is if I had a server, I could go out and actually show you how this is done. Unfortunately, I don't have that configured right, so what we'll do is we'll move on to the next section. So in WS-HTTP binding, there's a couple of modifications that we need to look at when we're not doing the basic, and that is going out and talking about the security context. We can turn that off in the app config and set the established security context property on the WS-HTTP binding to false. Alternatively, if security sessions are going to be required, it is possible that we can use stateful security sessions to basically go out and describe what that secure sessions need to look like. This allows the service to remain stateless, as all the state information for the security session is transmitted with each request as part of the protection security token. Note that when we establish the security session, it's necessary to use a custom binding or a user-defined binding in order to make this work, because it's not exposed during using the WS-HTTP binding or the WS dual HTTP binding that come out of the box. So those are the two pieces that we need to look at there. Now we're going to talk about how it is that we can take our service and deploy it out to a different deployment environment. Specifically, we're going to look at how we can use IIS to go out and do that. The WCF service that is deployed out to IIS takes advantage of what IIS has to offer. Things like process recycling, process health monitoring, and the message-based activation, as well as the idle process shutdown, which will shut down unused threads and allow us to have better scalability on the given server. This hosting option requires that we have an IIS server that's properly configured, but doesn't require that we do any hosting code as part of the application to go out and host it. This type of hosting will work with the HTTP transport, but doesn't work with the other ones. So what do we need to do when we go out and do the deployment? What are some best practices that we need to be aware of? After we have installed and configured IIS, we need to take into account a number of different steps to make sure that the application is going to host correctly. One of the most important aspects of doing this deployment is related to security. And in IIS, the ASP.NET user application must have permission to the application directory where all the service files are going to reside. What that means is that the service that's running IIS in has to have access to that directory. And inside of that directory, we're going to put in all of the SVC files as well as the other assembly DLLs that implement the contract that is part of that. And then the web config also needs to be in that directory so that it can give us the configuration for how we're going to go out and run the given service. So we're going to do a demo here, and we're going to go out and we're going to literally step into how we deploy out and build a service. So if you're running right now, you press the F5 key, you can see my full screen. And what I'm going to do is go into a virtual machine I have set up here. I happen to be running Visual Studio 2008 Beta 2, which is the Orcus release coming out very soon. And if I want to, I can go out and I'm going to create a new project. I'm also running this as an administrator. And what we're going to do is we're going to go out and we're going to create a starting point as being a WCF service library, which will host out the service that we want to run. So I'm going to call this my WCF service service host. Or actually, this is just my WCF service SVC, and we'll put this into C demos FMC done. So WCF SVC is going to be the service that we're going to go out and create using the service library. And this gives us our basic starting point. And if you've seen the other webcasts, you know that from here I've got a file that's got my implementation or my contract laying out iService1. I've got a couple methods, one that's get data, the other is get data using the contract. I also have a service file that goes out and implements this so that it goes out and returns the values based on what is out there. And then I have a configuration file that lays out how this is all run. And just to show how it works, go out and start the debugging. And with .NET or with Visual Studio 2008, it comes with the WCF service host that will allow us to go out and make sure that our application is working. Now, out of the box, once the host has started the application, a client, WCF test client, comes out and loads that service so that I can go out and make sure everything is working. You can see I can go out to my get data, put in a value here, say 4, click on the invoke, and it's actually going to go out and invoke that message against the service that we went out and created. Now, what I want to do is I want to take this service that we've created and I want to host it inside of IIS. And I want to host it on my machine. And so there's a couple of pieces that I need to do, a couple of things I need to do in order to make this all work. And before we actually write the code for this and add the project, I need to configure my machine to make sure that it has the appropriate set of rights and access to the server that it needs. And so inside of Windows Vista, if you happen to be running Vista and you're doing this, that runs IIS 7. What you do is you go to your program files or programs and features, and then you turn on and off the appropriate rights for the metabase. And so what I'm going to do is I'm going to go and do this and just show you where this is done. I've already actually stepped through this before now, but you need to make sure that you've got this turned on and set up so that it'll work for your application. So once these features open up, there's some configuration that we do on IIS, and then there is also a few settings that we need to add, or evidence that we need to add to some processes. So the first one is to go out into our Internet Information Services, and we need to make sure that under the management compatibility that you have got turned on your IIS 6 metabase configuration compatibility. And what that gives us is the look and feel of the metabase that drives how IIS works, allowing it to basically make everything else work the way that it needs to. The other part that we need to do is actually two things. One is under our development, turn on the ASP.NET. By default, that is not turned on. And then under the security, enable the Windows authentication. That allows the IIS service to be able to authenticate and figure out what the process is that's running and then give them the appropriate set of rights. Once you've done that, then the other thing that you have to do is you need to configure and add some basic evidence to some of the processes and service executables that are used by this. So if you go to your program files /Microsoft SDK /Windows /V6OA/bin, inside of here there is a utility called StrongName SN that allows us to add evidence to a given executable. The executable I'm going to add this to is what's called the IIS resolver.dll. That assembly resides in your program files, Visual Studio 9, Common 7 IDE. And when you run this, what it does is it goes out and it adds a verification entry to that executable, which means that the service, the host or the server can then use that IIS resolver to process things. One other thing that you need to do is take the service util executable and add a verification entry for that as well. The reason why is that that is used by the service host in order to go out and run things. And then change your directories over to Windows /Microsoft.net, Framework v30, and then go to the Windows Communication Foundation. And inside of this directory, there's an executable that's called Service Model Registry, or Service Model Reg, which adds a number of different entries to your machine so that it is able to go out and process. So you run that -i, and it basically goes out and installs all of the components that we would need to support IIS hosting our WCF service. So that is just some of the setup things that you need to do. I'll be adding a post to benkotips.com later on to kind of step through that, and I'll provide the directories for that as well. Now, let's go back into Visual Studio, and what we're going to do is we're going to add a hosting process, or basically a website that's going to host our service. So our service 1 lives here. We're going to go out and we're going to add a new website. This new website is where we're going to actually host the service, and so I can actually take the WCF service here, and we can put this out here, and I'm going to put this using HTTP. I'm going to bind this out to my local host, and we'll call this my WCF service, and we'll call that WCF SVC host. I think that's a new site. Say OK. And what it does is it goes out and basically assumes that I'm creating a brand new WCF service inside here. And what I want to do is I want to host the service I created in the library instead. So if I take a look at the files that it created from that template, I've got a service implementation and a contract. We're going to delete both of these because I don't need them. And I'll delete that one. And then what we're going to do is we're going to add a reference to our project that has the service that we want to do, the WCF service. So click on Add Reference. That opens up our references box here. And click on Projects, and you'll see there's my WCF service. And what this does is it adds to a bin directory the assembly that contains that service, basically all the code and all the processing, all the functionality of the service that we want, the service library that we want to expose through our site. Now, on WCF service, there's one other file that got created for me, my service.svc file. And inside of this file is the definition of how we're going to go out and actually do this. So if I double-click on service here, you'll see the name here needs to be changed to be WCF SVC, and the name of this service is Service 1. We'll put that in here. We'll get rid of the code behind because we don't need that. And then, once we've done all this, then we need to change our web config file to be aware that we're hosting the WCF service and not our own. So down inside of the WCF service configuration, if you scroll down to where system.service-model is defined, and I guess that's all the way down here, you'll see that here's my services and then my two bindings. And what I want to do is I want to change the name of the service that we're exposing, not to be service, but I want it to be my WCF SVC service 1, and the implementation of the contract is going to be WCF SVC.iService, and make sure we say iService 1. And that is the configuration that is going to point out when service is called, it's going to basically take from our assembly in the other spot the information it needs to know how to go out and connect to that service. And so, as we go out, we should be able to take this and let's build a website. And we see that it built successfully. We should be able to go out to the service right here, right-click and say View it in the browser. And this goes out, and you'll see that it brings back a couple of different things. This is like a ASMX service where it basically provides you a harness to be able to go out and test your service. But with WCF, it's not really creating a test harness so much as showing us how we can get to the WSDL. And if you click on the WSDL here, you'll see that that gives us all of the functionality that this WCF service is currently exposing. And we can take that and we can use that then to be able to test and work with this. So once we've done this, I can also take my WCF test client, and I can then say, hey, use this, let's go out and run the test against this particular service without even having WCF test service out there running. So if I go out to a command prompt for Visual Studio 2008, and I type in WCF test service, test client, that goes out, starts up my WCF test client. We can go ahead and say we're going to actually attach a particular service, and we'll paste in here the WSDL for that service that we're going to be testing. Now when we do this, you'll see it's going to go out and it's going to add that service, and it's running it from my IIS website. Notice I don't have the web service host running down here. Basically able to go out and access it. So it'll add the service here, and while we wait, there we go. We can see that we've got our get data. I can put in a value, say 12 or 13. Let's use 12. Lucky number, and click on invoke, and this should then go out and test our service for us and make sure everything is working. And you'll see there it goes. It returned 12. We are running this through the IIS environment. So going out and hosting a service in IIS is literally a matter of creating a service file and then appropriately adding the correct information to the web config file to be able to make out and make that work. So let's go back into our slide deck here. And some of the advantages of, or some of the things that you can do inside of Windows Activation Service is you can work with non-HTTP bindings. So if you're doing TCP or named pipes or MSMQ, you can host those inside of WAS. And the Windows Process Activation Service has a very similar deployment capability. We basically go out and create the service file and then add the functionality to it. But this allows us to have a number of different protocols, and we do this using a listener adapter. The listener adapter interface communicates with the activation request, which then go out and start our service when we need it. We can support the non-HTTP type of protocols, and just as in IIS, we don't have to write any hosting code in order to be a part of the application when it's hosted by WAS. Deploying to WAS requires a couple of different things in order to make sure that we are successful at hosting that. And just as we did with IIS, the first one is that the IIS must adhere to the appropriate protocols. And then assuming that we've got the protocols, we've got to have a service file created, and that service file is defined up for the type of service that we're going to create. This could be for TCP or MSMQ or named pipes or what have you. But once we've created that, then you can go out and you can define the implementation of that contract in the service class itself. And so we go out and we build that class, and then again we've got our web config file that is going to take all the configuration settings and put them into the appropriate place that needs to be in the same directory as the service file, and then can be deployed from there. After we have all these files, we can copy them to an IIS virtual directory where Windows Activation Service will look when the request gets processed and handled. Now, there are a number of different transports handled by WAS, depending on WCF. It follows the same a similar pattern regardless of what our transport protocol really is. Another consideration with deployment is the client application. And that is looking at how can I go out and take my service and then make sure that the client application is able to connect up to it. Client applications using the WCF need to be deployed or can be deployed using what's called a Click Once deployment. Click Once is a technology that allows us to take advantage of runtime security by looking at the code access security stuff, and then make sure that we've got a valid application that's running. And it basically works by having a deployment manifest that Click Once goes out and checks to see whether or not the client has installed all the latest pieces and parts it needs in order to be able to run the application. If they're not there, it'll download the latest version of it and then be able to go out and run. It also takes advantage of some security signing by taking a key and digitally signing all of the components of that application. Now, these components are running from a trusted publisher store, and the local security policy on the client machine needs to be configured to grant full trust to applications signed with that publisher's certificate. This signing really ensures that the installation files are valid when we go ahead and download them and then use them. So using Click Once, what happens when I click on the application to go out and install it is it goes out, checks the manifest to make sure that I have the most recent version. And if I don't, it'll download those components to my machine. Then it checks the signature on each of the files that gets downloaded, make sure we aren't getting a bad or some kind of a fraudulent version of things, and then installs them on my machine and then goes ahead and runs the application. And Click Once can be configured in a number of different ways to allow online and offline application running of that. Let's go out and let's show what this is going to look like by going out and building an application. It's going to take our service that we just created, and we will deploy it out using Click Once to a given website. And one of the things I'm going to do is I'm going to deploy this into the same directory that we have our WCF service host sitting in. So what we'll do is we have our application out here, WCF service, that is being hosted out on this website. And what I want to do is create an application that's going to use that. So we'll add a new project to this. And inside of our project, what we'll do is, I know I've been doing a lot of C# lately, but maybe we could do this next one in VB. Go out and create a Visual Basic project. We'll do a Forms application. We'll call this our WCF client. And the WCF client application is going to go out and exercise our service and run through the basic processing things that we've got here. And so here's my form, and we'll put some properties on here. Call this our Click Once demo app. And so get on the form here and call this my Click Once demo app. And what we'll do is we'll add to this a button, and put the button over here. We'll put a text box on there. Text box is where the user will go out and type something in. So here's my text box down here. Drag that on. And then once they click on the entering the stuff up, then we will go out and we're going to take a label and we'll set the label text equal to the value that is being processed out here. Now, on the button, we'll set that text to be invoke, not invoice. We'll go out and invoice someone. Double click here, and we're going to go out, and you'll see that here's my button one click. Now, in my solution, in order to be able to access a given service, I need to have that service WSDL added as a client. So what I'm going to do is I'm going to go down here and I'm going to add a service reference. We'll pass in the WSDL for that. Click on Go. And what this should do is go out and show me that I've got my service one out here that has the methods for get data and get data using the contract. We'll go ahead and just add this. Say OK. And now, inside of my solution, what I'll have is a couple of things created for me, and that is the service reference. If I take a look at the service reference to a show all files and look underneath here, you'll see that I actually have several files created. Let me do an Alt-Enter to make it big. Give us a little more screen real estate. You'll see here is my WSDL. If I double click on that, it actually shows me the same WSDL that we had pulled up before. WSDL being Web Service Description Language. I also have a service map, some information, and then some schema that defines how this is going out and being worked. If you want to take a look at the code that got generated, you can see under the reference.vb there's code that goes through and actually implements that service call. So there's my Boolean value, string value, and I've got property changes and all of the different methods for going out and doing binding. And then down at the bottom you see here's my get data that returns the base channel get data and also get data using the contract. This code here, if you did in C# you'd see it's the same kind of code, basically is regenerated. So if I was to go out and make changes to this code, the next time I update my service reference it gets regenerated, so you don't want to do that. Inside of our form here, we want to import that namespace. So I'm using import, and we're going to import my WCF service, WCF client app, and we're going to pull in my service reference. And that way I can then go out and use that inside of the code that is being processed out here. Now, when they click the button, we're going to go out and we're going to create an instance of my service reference. So here's my service client, and I'm going to basically go out and create a service that is that service client is equal to a new service reference. Here's my service one client. And then, meant to do this. There we go. Actually, we'll do this. We're going to, I'm speaking C# here. So I'm going to dim SVC as service one client, which is equal to a new service one client. And then what I'm going to do is I'm going to set my label one's text is equal to SVC dot get data, and we'll pass in the data here. And we're going to take a integer, and we're going to do a parse on that, and we'll pass in text box one's text. And so basically what's happening is this label is going to be set equal to the value from the service, going out and calling that get data. So from here, what we'll do is go ahead and test this, and we'll test this by going up to my WCF client app and debug start a new instance. And as you can see, here's my instance. If I put in, say, 4, click on the invoke, the application should be going out and invoking my service. And while we're waiting, if I had been writing a nice, good application, I should have put a something saying that the there you can see I entered 4, and it's just basically telling me that I went out and invoked it. If I had been doing a good code, I would have set my cursor to be an hourglass or something like that while it's running. But basically that goes out and tests and verifies that the service is actually going to run the way that I would expect it to. Now what we want to do is we want to take this application and we're going to deploy it out so that other users are able to get out and use this application. So you go to the property pages of your client application, and if you come down to the Publish tab, you'll see that down here under Publish we've got a couple of things that we can do to basically take all of the resources that make this application work and be able to publish it out to wherever it needs to go. We can specify a folder location, and in this case I'm going to go out to HTTP, I think it's msampc / and then we'll call this, what do we call our server? WCF service host. And that'll be the same URL as our web project that we've got this hosted in. That way I can see what's coming out. I have an opportunity to specify application files that maybe need to be deployed with this. You'll see that this is dependent on the 3.0 framework. So we've got the service model and a couple of other components that are part of this. I could also specify additional prerequisites. So if I wanted to be able to deploy out SQL Server Compact or report viewers or other components, I can add those to what gets deployed out. I also can specify how I want to do updates, whether or not this application should check for updates when it runs. If you turn that on, it's going to basically, the client will go out and see, is there a new version of this application available, and if there is, download it before we start. I could also specify a minimum version of the application. Where that is useful is that if I have updates that I don't require, that I want people to be able to get if they want to, they can leave that unchecked until you make a breaking change. That means that no longer will the older versions work. Like for instance, if I have a database change, and maybe we used to have a 5-character product ID, and now we have a 6-character or something like that, you can specify the minimum version required for the application to run. We can also go out here and in the options specify that we're going to create a publisher name. This would be Benko Tips as our publisher. We can put a product name, client, WCF, demo app, put in a nice support URL, deployment web page, etc., publish.htm, and we can automatically generate this web page after every publish, and then open that page when we get done. We can also, if you wanted to do a CD installation, you can have it so that it creates an autorun.inf file. That means that when the CD gets plugged in, it's going to look for the existence of that file and then run the publish.htm if you want to do that. You can validate any files on the server that are uploaded so that after it finishes the uploading, you can check things. You can also have a number of other options that are available for how you want to do the publishing of this. And then we have our published version, and this is automatically going to increment each time we publish. So we'll click on the Publish Wizard and just kind of step through this. So here's where we're going to take the server, and we're going to publish this out. We'll click on Next. And then we're going to create the application to be available offline or only online. Where this is useful is if I have an application that I do not want to, for instance, have it allowed to be run when you're not connected to the internet, like for expenses or something like that, you can restrict the application. I'm going to leave it with the default there and just go ahead and click on Finish. And this is then going to go through the publish process. And if I was to go out and take a look at the output, what I should see is that it actually went through, built the application, and then created the page. So here's the application being built, creating the publish page, and then you'll see it takes me to that page where I can take a look at this application. Notice my publisher is Benko Tips. So we already got our WCF demo application out here, version 1.0.0. And the following prerequisites are listed. If those are already installed on my machine, then I can go ahead and click on Launch. Otherwise, I can take this page and pass it out to whoever needs to go out and run this application. When they click on the install, what it does is it goes out and downloads the appropriate setup file. We're going to go ahead and run this, and then we'll just go ahead and click on Run. If I had a certificate that was had a root publisher, then I would validate that the publisher is correct. Now, right here you can see that it's actually launching the application, and this is verifying all of the requirements that are part of that application manifest. And I'll show you those files here in a second. But while this is going out there, checks to make sure we have the right versions, does the actual install, and then starts up the application. And you can see here's my click once demo app, put in our value, invoke it. It should go out and it should run that instance of the application. There's 444. See, hey, it's working great. What actually got created? Well, if we go back to our solution here, make my solution provider a little bit bigger, and I refresh this and I show all files. So I'm going to turn on Show All Files. You'll see that it created a couple of different things. One is the publish.htm file. That is that web page that we saw right here that has all the information that lays out what this is. So this is where I could customize the look and feel of what that page looks like. So double click on it, you can see, hey, I can go out and I can change, go to the design, have all the content that you want. The other thing is that it includes the setup.exe, which is executable. It'll actually go out and do the setup. and then I have my application file here, and then I have application files that are tied to a particular build version of this Click Once application. So here's my application file. I've got my configuration deployment, the actual executable, and then the manifest, which is going to go out and specify all of the components that need to be a part of this. And if we make this open up here a little bit so I can see, you'll see that here's the application runtime. We've got the current version. You have signatures for the public token key for checking the hash of these files that get downloaded and how they all work. And if you want to spend more time on that, you can see that we've got just lots of good information on how that Click Once application is actually going to be processed together. And if I go into my WCF client application, you'll notice that it created for me, when the Click Once deployment ran, this temporary key that it uses for doing all of those signatures on the client that gets sent out. So as you can see, going out and creating a client application and using Click Once to do our deployment on this is actually a pretty easy and straightforward process to go out and do. The files that get created are all, again, pretty basic, pretty straightforward as to what those include, and they allow the whole process to go out and just work for us. So let's go back now. Click Once is great technology for deploying the application, but we still have some of the things that are going to enable us to get more resource consumption and performance by looking at how we can use throttles and quotas to basically go out and increase our performance. So what we've got is two main ways that we can limit how much resources, how many resources are used by a given client running the application. These include quotas and throttles. And what a quota is it's a limit. It's a limit that says once you reach this quota, we're done. We're only going to support up to a certain point of processing. And once you reach that quota, the service is basically going to prevent further processing on things. The throttle, on the other hand, is not going to necessarily throw an exception when those limits are reached, but we can create a throttle that is going to limit how many concurrent things can run. And so it'll basically queue up and wait for processing to finish before it adds more processing to it. So it's basically limiting how much, how big the pipe is. Where the quota says how big is the bucket that we're going to allow it to fill up. The throttle allows us to specify how much flow, what's the rate of flow that we're going to allow. So if we look at these, when the trace is run, we've got a number of different things that we can limit out on how these are being processed. And this is good if we're trying to prevent denial of service type of attacks. There are a number of different levels that we can do these at. These are designed to be allow us to set up, for instance, a maximum message size of a certain number of bytes, 65,536 bytes. The reason why we've got a default on that is because we want to prevent denial of service attacks where it makes sense. If you're doing a lot of streaming or something like that, you may want to adjust what those throttles and the quota levels are. An example of a serialization quota is like the max items in an object graph. This specifies how many objects can be in an object serializer and when it's serializing. We also have things like the number of concurrent connections and limits on what that is. These controls are designed to provide an out-of-box mitigation against certain types of attacks and improve the performance metrics of things like our memory usage and our startup time. But depending on the application, these can also reduce how the application performs, and in some cases, it may even stop the application from working at all. For instance, if you've got an application designed to stream video, you can easily exceed the number of the default maximum received message size property. Using these throttles, most throttles and some quotas are available at the application level, even when the base property of serialization is a serialization or a transport type of a constraint. These defaults for throttling and quotas have been chosen to enable the largest range of basic application functionality while providing basic protection against common security issues. It's possible that when you design that you may need to exceed these default values, in which case you need to review them and make sure that they are set according to what your application needs actually are. So if they're set too high, then you can go out and you can review them and pull them back. Exceptions can happen at runtime that are not necessarily visible at the application layer, and these errors might not be handled by the custom iError handler implementation. But if you are in a development environment like Visual Studio, most of these exceptions are going to be displayed automatically when we're out there running. WCF, regardless of this, has capabilities, will log this stuff out into the logging and the tracing location. So we can use that tracing to be able to capture and see what types of performance activities are actually happening when our application is out there and running. So what we're going to do is we're going to go into our application that we created, and we're going to look at how we can adjust throttling and look at some of the quotas and see what the impact of this is on our application. Now let's go back into press an F5 key, and you can see my full screen again. And what we've got is, here's my application. There's the website that's got this. Here's the web config file that I want to go out and work with. Notice when I right-click here that I can go out and I can click on Edit the WCF configuration of that website as well as any other site. This allows me to use the configuration editor to get into some information about how we're going out and setting up things for throttling, etc. Now the first thing we're going to do is we're going to go to the Diagnostics tab, and you can see that I can have tracing is turned off by default, and I can enable that by clicking on the Enable Tracing, and then I can specify what level we want to do our tracing at. I'm just going to do it at the warning level because I'm not interested in getting verbose information. We did that, I believe, last week. But we are going to look at the full messages that are coming down. So if I take a look here, you can see that I'm pulling in information, including the timestamp, date, time, etc. The other area where we want to go out and do some tracing or work with is looking at some of the throttling and the quota that we have on the messages. Now, these the tracing that we can go out and generate. We can basically go out and run our process and see if we want to take a look at that, and then we can use the trace viewer to see the actual content of those messages. We'll come back and do that after we run it. But what I want to do is I want to take a look at some of the throttling that we can do on the surface. And throttling is where we limit how much information is going to go down through. That is, if I take a look here under my advanced, you'll see that I have down here under the service behaviors the ability to take a look at some of the service behaviors that are out there. So what we're going to do is we're going to go to the service behavior. We're going to add, and you can see I can add a number of different things, but one of them is my service throttling. Here's my data contract serializer, persistent information, authorization, etc. We're going to set some throttling on the service and then limit how much information is going to go out to that. So if I double click on there, you can see that here is my maximum number of concurrent calls. And what we'll do is we're going to throttle this back, and we're going to say we're only going to support 2 calls at a given time. I can also change the number of concurrent instances, and this is how many instances of this service can I have running. And you'll see that by default it's set to a pretty large number. We're going to throttle that back down to be, say, 10, and then we can go out and we can save this, and we can then run our application. So what we'll do is we'll save this, and then if you take a look at our web config file, which just got recreated here, and scroll down here, you'll see that what it has done is it has added a couple of behavior nodes. One is my service throttling, which lists out the maximum concurrent calls is equal to 2, and the concurrent instances is equal to 10. Now, let's go ahead and we're going to run this by saving our application here. And once we save all our files, then I'm going to go out to my client, and where that lives is it just got installed on my machine. So we'll go down to WCF client. Actually, we can just go here and run it from here. Start a new instance. And what this will do is give me my Click Once demo application, put in 4. And if I go over here and we start another instance, then what I should see is I've got not just one, but I've got 2 of these instances out here. And actually, I started the wrong thing here. So what I want to do is take this and start a new instance. And do it again. Take this and start a new instance. And so we can go out, we can invoke it the first time. And since this is a Click Once deployed application, I should be able to come down here to where this has been installed and start up another instance of that. So I believe I created it here. This might be for the demo app. That's a demo app I created before. So let's go to the publish page. And we'll install and run it again. So here's another instance of the application. We can put 5 on there, invoke it, and then we can install a third and run it. And we'll go 6 and say invoke. And at this point, I have exceeded the number of concurrent sessions that are out there. And if I invoke this, and invoke that, it should actually be throttling this down. So put 1, 1, 1, invoke, invoke, invoke. And if I was to increase the throttling on that, then I would get an exception thrown saying that I had exceeded the number of concurrent processes that can be out there running. Now, if I take a look here at my files, and what I should see on here, let's stop our process here, and then refresh, is I should be able to get to where my service trace file got created. And let's see. Anyway, when we went ahead and created our web config file in our WCF configuration, we could specify exactly where we want our tracing to go by going into diagnostics and then taking a look at this trace listener, which is running from inetpub WCF service host, and I could put that to somewhere else, but because it's running through IIS, I can't get to it. But the idea is that I can control the throttling of how much information is going to be processed through this service, and I can do that on the service behavior by going down to where I've got my service throttling running. So I've got my number of instances that are running. Now I can also go out and I can take a look at the actual service configuration itself. And if I take a look at the services in the behavior configuration for this, you'll see there's my service, and I go to my endpoints. You can see here's my service configuration. I can edit what that HTTP binding is and actually put together some additional throttling or quotas on how this is going to be limiting what the service can do. So for instance, right now we've got a maximum pool or message receive size of being very large. If I set that down to be 1, which is very small, and save this, and then run the application again. So we go out to our Click Once demo application and put a 3 on there and invoke it. Now we're going to get that exception thrown because the throttling or the quota has been exceeded, and so now every time that it runs beyond this, it will throw that exception. And so we'll go ahead and quit there. But the idea is that then I can limit how much or what the maximum message size I want to have on this application. We'll set it back to 10,000. We'll go ahead and save this, and basically we're done with the demos here. So this code that is part of this application right here, the WCF service solution, I will post on benkotips.com here once we get done with this, and I'll add a blog post that has some links to additional information on the processing. and then you'll be able to go up and get to it from benkotips.com. By the way, I added this new community page called a blog roll, and what that is if you have a blog and you want to have some cross-posting, promoting of it, go ahead and send me an email with your URL and some information about what it is you're trying to do with your blog, and I'd be more than happy to add it to the blog roll page on Benko Tips. Kind of a new thing I'm trying to do starting this week. So let's go back into our application. And what we've done is we've covered a lot of great information about how WCF, the performance and deployment of the application. Load balancing of WCF is very similar to other web applications, especially if it's using the HTTP type bindings. You can take advantage of the same load balancing tools that are part of any other HTTP application. The options available for deploying this, Click Once is a great deployment capability. The idea is that it's very easy to go out and do some deployment of the applications to the clients so that they can use your services. And then you can increase by looking at your quotas and your throttling, you can increase your performance and resource consumption by taking advantage of the tools that WCF provides out of the box. So with that, if you're interested in getting more information about other webcasts in the series, go out to benkotips.com/FMC, the FMC Framework Masterclass, where we talk about Link and the Windows Communication Foundation. I'll be adding some more webcasts to that here in the next week for December, where we'll start talking about some of the other components that are part of the framework. Also, MSDN events, our live events where we travel the country and show what's going on. Go out to msdnevents.com. So with that, there's a couple of books that are out there on WCF worth checking out, also from Microsoft Press. But we're now to the question and answer, so I'm going to turn it back to Bennett, and then I'll go out and check the queue. If you have questions, go ahead and put them in the queue, and I'll answer as long as we have questions in there.
Okay, thank you, Mike. I'd just now like to take a minute to share some additional resources for the Microsoft Live Viewing program. We will begin our final question and answer session in just a moment, and once again, you can still ask a question now by typing your question into the field next to the Ask button in the question and answer pane. In a moment, you'll notice a survey for today's event on the screen. I'd ask that you please take a moment to complete this evaluation by following the appropriate link on your interface. Your comments are very valuable as they help us create better webcasts for you. And finally, in order to view a replay of today's live event or to register for upcoming webcasts, please visit www.microsoft.com/webcast. And I'll hand the floor now back to Mike to answer the questions that we have come in.
All right, Bennett, and thank you everyone who participated today. We've got a couple of questions in the queue. The first one is talking about, is there any standard for the number of service contracts and service endpoints that get created? In other words, does the number of service contracts and endpoints affect the performance of the application? Depending on the type of binding that you need to go out and do, out of the box it's going to generate for you two endpoints. One is going to be your WS-HTTP binding, which is the default binding that WCF allows or it provides out of the box, as well as a metadata exchange endpoint. And the number of endpoints you need to create and whether or not it affects the performance really doesn't affect the performance having a number of different endpoints. It's just the number of endpoints that you provide increases the number of types of clients that can go out and use that. I'll go ahead and type the answer to that here in just a second. The other question is coming in on the code that we wrote on the server side and the types of things that we're talking about for performance being configured from the server as opposed to from the client. And does the WCF provide anything on the client to affect the performance of the application? And on the client side, because it's literally just going out and connecting to a port or to a socket, it's pulling information in and out from there. And so the types of configuration that we're doing really is more server-based as opposed to otherwise. That is what I have in here for the questions. If you have any other questions, go ahead and put them in. I'll stick around for a little bit. But without anything else in there, I guess we're pretty much through. So I'll answer questions if you have any. Thank you for joining us. Hopefully we'll see you next time. And then go out and check out Benko Tips. Let me know if you have a blog you want to have promoted on benkotips.com. Thank you again.
Thanks again, Mike. You'll now notice that survey on the screen right here. And if you just take a moment to complete that evaluation, we'd really appreciate it. And once again, I'd like to extend thanks to Mike Benkovich for today's wonderful presentation, and I'd also like to thank everyone in the audience for attending. That does conclude today's live meeting webcast. You may now disconnect from the audio portion of this conference.